Hello guys, today I will solve IMO Shortlist 2019 problem N8, which was the hardest one in the number theory section. In this problem we are given a and b, two positive integers, and we need to prove that a square plus upper bound of 4a square over b will not be any perfect square for any a and b. And now let's assume that this is not correct, so a square plus 4a square plus e over b equals some number c square. E must be less or equal to the b minus 1 and greater or equal to 0. So this is remainder of 4a square minus 4a square over b, and negative value of this remainder. And now if we multiply everything by b, we get that b plus 4a square minus b times c square plus e equals to 0. Now if we look at this equation, this is not symmetric for a and c. And in most of the problems like this, it's very useful to make equations somehow symmetric. And at first notice that c is more than a, because a square plus some positive number equals c square. So c must be more than a. And now we can assign c as x plus y over 2 and assign a as x minus y over 2. And now we write our equation in terms of x and y. So we will have b plus 4 times x square minus 2xy plus y square over 4 minus b times x square plus 2 times xy plus y square over 2 plus e equals to 0. Now if we eliminate the common terms, we get that x square, because we have b plus 4x square and minus bx square, x square, we have also plus y square, and we have 2xy in both of these terms negative values, so we will have minus b plus 2 times xy and plus e equals to 0. Now if you look at this equation, this is symmetric for x and y, and now we can apply Vieta jumping technique here. If you haven't heard about this technique, I will link the video about this one in the description so you can look at it. So now let's assume that x is more than y, and the Vieta jumping technique tells us that we can generate new solutions which will be smaller to the previous one. Now assume that we have found such x and y, and their sum is minimal and x is more than y. So we get that x square minus b plus 2 times xy plus y square plus e is equal to 0. Now, how can we generate a new solution from x and y? Because we know that the sum of the solutions of this equation, sum of the solution is b plus 2 times y. If we discuss this equation in terms of x, the second solution must be y and b plus 2 times y minus x, or another way is y and y square plus e over x, because this is the product of the roots, y square plus e. Now if we manage to show that y square plus e over x, this number is less than x, then we will solve the problem, because we have found the solution from different from x and y, which has the minimum less sum than this one, and our assumption was that x and y was the numbers whose sum was minimal. So y square plus e must be more than x squared, otherwise we will solve the problem. So this means that e must be more than at least 2 times y plus 2, because x is more than y and x is greater or equal to y plus 1. So x squared would be greater or equal to 2 times y plus y squared. So e must be more than 2 times y plus 2. And what do we know about what e is? That e is less or equal to b. So we get that b is more than 2 times y plus 2. And now, by using the fact that these two numbers must be equal to each other, and if we write instead of b 2y plus 2, we will decrease the first equation. So second one must be more than first one. Instead of y, we can write y minus 1 plus 1. We will see why it's useful in the end of the solution. So we will have b plus 2 times y minus 1 plus b plus 2 minus x. This equals to y squared plus e over x. Now we will decrease the left hand side by inserting 2y plus 2 instead of b. 2y plus 2 times y minus 1, 2y plus 4 times y minus 1, plus b plus 2 minus x must be less or equal to the y squared plus e over x. Now we have assumed that e and x, both of these numbers, are greater or equal to 2. It can be seen that this is very obvious, because if one of them is 1, then we can get the answer very easily. So what is their product? This would be 2 times y squared plus 2 times y minus 4 plus b plus 2 minus x. This must be less or equal to the y squared plus e. Now if we multiply everything by x, we get 2 times y squared x plus 2 times yx plus bx minus x squared minus 2 times x must be less or equal to the y squared plus e. Instead of x squared, we can write y squared plus e. So we will decrease the left hand side much more. So we get 2 times y squared x plus 2 times yx plus b times x must be less or equal to the 2 times y squared plus 2 times e. Then we can also add 2 times x here. So because we know that x is more or greater or equal to 2, we can easily see that 2 times bx would be more than 2 times e, because b is more than e and x is more than 2, greater or equal to 2. Similarly, we will see that 2 times yx would be more than 2 times x, because y is also greater or equal to 1 from this fact. And because x is greater or equal to 2, we get that 2 times y squared x, this must be more than 2 times y squared. And clearly, this is against our inequality that left hand side always must be more than right hand side. So our assumption was correct, that y and x was the minimal sum, because we can always decrease. So we have used Vieta jumping very well, and we got that this equation must not have any integer solutions. So we have seen that we cannot find any numbers a and b in the problem. They are a squared plus upper bound of 4a squared over b must be some number perfect square, like c squared. If you got any questions about this technique or solutions, please write in the comments, and don't forget to like and subscribe my videos.